Hi everyone. In the first half of this section, we talked about looking at two different functions and putting them together, performing operations with them, either adding them together or subtracting, multiplying or dividing. What I want to talk to you today about is a composition of functions or a composite of functions. It's sort of what you're putting one function into another function. You're putting one right after another is maybe even better to say it. So let's say I've got my function f and I put my input into f, my x. My x goes in. So what comes out is my output or my value of f for that x. My f of x is what I get out, whatever that is. That's sort of like my y. Then I take that output and I put it into g. So that f of x or my y's answer goes into g. And I put that into g, and then what I get out there, my output of g is g with an input of f of x. Now, did that thoroughly confuse you? Whew, let me walk through it with a few functions, and then you'll see it's not as complicated as I just made it sound. If you see something like this, where you have g and you have this tiny open circle, closed one would mean multiply, but this is a little open circle. This is g of f of x. So basically what that means is g of f of x, which means this: start from the inside and work your way out. You start by taking f of x, that function, and putting it into g. That's what this means. So put f into g. If I had f of g of x, then you would put g into f. You're working from the inside out. Okay, so here's my two functions. I have f of x and g of x. F of x is x minus 5. G of x is x squared. And I want to know what's g of f of negative 3. Which if I rewrite it this way, it's the same as saying, and you will see it written this way, g of f of negative 3. So what that means, start from the inside out, put negative 3 into f. You put it into the x. If that function has more than x, like let's say it's a quadratic, x squared plus 2x, something like that, every place there's an x, you would put this input. So we're going to put negative 3 into f first and see what comes out. So if I put negative 3 into f of x, I have negative 3 minus 5. Negative 3 minus 5 is negative 8. So f of negative 3 is negative 8. Now I'm going to take that output and put it into g. So I'm going to put negative 8 into g. G is x squared. So in place of the x, I'm going to put negative 8, negative 8 squared, and my final answer is 64. That's the way this works. By the way, composite functions are not necessarily commutative. You cannot assume that you can rearrange them and you'll get the same answer. G of f of x is not the same necessarily as f of g of x. Let's keep the same two functions and let's find what's f of g of negative 3. You will see this a lot in your work and probably on the computer as well, so I want to make sure you're familiar with it. My favorite way to write it is like this. I just think it's a little clearer to see what to do. But either way, what this means then is first you're going to put negative 3 into g. You're going to see what comes out. Whatever comes out of that, you're going to put into f. See how you work from the inside out. So if we put negative 3 into g, then we're going to go negative 3 squared. That is 9. So this is equal to 9. So now we're going to find f of 9. We're going to put 9 into f. So we have 9 minus 5, and that final answer is 4. So f of g of negative 3 is 4. All right, let's look at a simple way that composite functions would work in real life. Let's say you're going to a pizza parlor and you have a coupon for $5 off. Awesome. You also have a this store, offers a special deal to students at your school. If you show your ID, they give you 10% discount. So the question is, how much would you save if you applied the 10% discount before the coupon? Actually, the question is, how much more would you pay if the cashier applied the coupon first and then the 10% discount? That's really what it's asking. So now you have two different functions. You have the coupon function and you have the discount function. So let's name our function for the coupon C for coupon. So C of X, whatever the price is going to be the price minus the $5, right? There's our function for the coupon. And let's come up with our function for the discount. So the discount is 10% off, right? So for the discount, we would take the price minus 10% of the price, which would be you're only paying 90% of the price. So the function for our discount is 90% of the total price. So that 0.9x would represent the cost applying the discount. Now let's look at what'll happen, the two different ways that we could do it if they applied the discount first. So if they apply the discount first, then you would have the C of D of X, right? So remember, I like to do it this way, C of D of X. So we're going to do the discount first and then apply the coupon. That's what that would look like. Or if we wanted to do the coupon first and then the discount, it would be the opposite, D of C, all right, of X. So that would be apply the coupon first, remember, because you're going kind of right to left, and C, then apply the discount later. How would that work? So now notice I'm leaving it X because I don't know what the price is. So I'm going to put one inside the other. So if I put the discount 0.9x into the D of X into C of X, in place of X, I'm going to put this function. So this becomes 0.9x minus 5. Do you see how I took this function and replaced it with the x? I put D of X into C, and I got that. Now I'm going to do the reverse. I'm going to put C of X into D. So this is 0.9, and in place of X, I'm going to put C of X, which is X minus 5. I just put C of X into D. And I'm going to go ahead and simplify that. This gives me 0.9x and minus 4.5 because I have to multiply 0.9 times 5 as well. I have to distribute. So which one gives you the better deal? And you can see right away, if you apply the discount first, you're paying, if you apply the coupon first, you're paying 50 cents more. Do you see that? 0.45 instead of 0.5. That 50 cents more if you apply the coupon first. If you apply the discount first, you save 50 cents more. Does that kind of make sense? What I like about this exercise is it shows you how to put one function into the other even when it's still X, because we don't know the price of the pizza. But here it would be 90% of the price of the pizza minus $5. Here it would be 90% of the price of the pizza minus $4.50 because we took 90% off of our discount. We don't want that, off of our coupon, I mean. So that's how these composite functions work. Okay, we are going to finish off this lesson with this is your lesson check, with your lesson check. F of X is 3x minus 2. It's the same 2 that I gave you yesterday. G of X is x squared plus 1. What is F of G of X? What does that mean you're supposed to do? What will be the result when you do it? F of G of X. Bring that in to show that you watched this video. We'll see how you do with that. And that's it. A nice short lesson today with composite functions, putting one inside of the other. And I'll see you guys next time.